Okay, so let's talk a little bit about vectors in space or vectors in 3D. We got a lot up here already, but if you remember when we talked about 2D vectors, we had these standard component vectors, I and j hat. Then they went in the x and y directions respectively. But now we have a third dimension. So I, j, k, right? Go down the alphabet. And we have these component vectors, instead of being 1, 0 for the I hat, it's 1, 0, 0. And 0, 1, 0 for j. And in the k case, it's 0, 0, 1. So now we can represent any vector v. So if v has three components, v1, v2, v3, we can simply represent that as the sum of component vectors. v1i, v2j, v3k. And again, that's going to be helpful as we move along to think about the components in any given direction. So I want to take a step now to talk about some of the properties of 3D vectors. Notice these are almost identical to what we saw in the 2D case. So if we have the suppositions that u is some vector in 3D, v is some vector in 3D, and we have some scalar c, could be anything, could be 0. Notice that u is equal to v if and only if each of the components are equal. So that's the same idea as in the 2D case, except that we have that additional dimension. Also, if we have 2 points in space, x1, y1, z1, and x2, y2, z2 is the coordinates, and v is that directed line segment from P to Q, then v is simply the distances from the initial point to the terminal point. Again, this is exactly the same as we dealt with in 2D, we just have an additional dimensional component. Similarly, the magnitude of a vector v is going to be the sum of the squares of the components under a square root. Recall again for unit vectors that any vector divided by its magnitude is a unit vector in the direction of v. One caveat here. That v can't be as the 0 vector, right? Recall that would be a 0 vector divided by 0, and everything would go squirrely when you do that. So we also have that u added to v is simply the addition of the components, simple. And scalar multiplication works exactly the same as in 2D. You multiply each component by that scalar. And really that's it as far as vectors in space go.